Hi! What is chemical equilibrium? In this video, we're gonna learn about chemical equilibrium. Chemical equilibrium happens when the reaction is reversible. When we talk about reversible reaction, we mean that there is a forward reaction and at the same time there is a reverse or backward reaction. So it says here that in a chemical equilibrium state, the rate of the forward reaction must be equal to the rate of the reverse reaction. Let's understand that further in a chemical equilibrium because the rate of the forward and the reverse reaction is equal, when we plot the graph, it will look like this. So if we analyze the curves here, we have blue and red curve. Blue starts at 0 while the red starts at a certain rate. In this case, if we are trying to figure out which is our reactant and which is our product, because the blue starts at 0, that means that is our product because we don't have any amount yet in the onset, during the onset of the chemical reaction. While on the other hand, because there is a certain value already at the start of the reaction, that means that we're starting with the reactants if we're talking about the red curve. And after some time, as we move along, the chemical reaction, these two curves will meet until they flatten out. A flat curve means that the rate here is the same for both. So this is the graph that will illustrate the chemical equilibrium in terms of rate, that the forward and the reverse rate must be the same. To continue, these are the essential concepts that you need to remember. In a chemical equilibrium, the forward reaction must be equal to the rate of the backward reaction. I hope that's already clear, which is represented by these graphs. Now, the second question is, what happens if the rate is equal for both directions? What's going to happen to the amount? Should the amount be always the same also, or will they matter? In the video on in the video I made on the demonstration of chemical equilibrium, and I hope you've watched that, you've seen that even if the scoopers are the same or not, eventually the rate of the forward and the reverse reaction will always reach to a point that the rate will be the same. But you've noticed that in the level of the container, the level or the amount of the products and the reactants need not be the same. So, in terms of concentration, we can say that the concentration is constant, not necessarily equal. So, in this graph, if you look at this amount versus time graph, you see another curve here. You see the blue curve and the red curve. So, that doesn't change. The blue always represent the product because it starts at 0 amount, and the reactants will always start with a certain amount because you always begin with your reactants. As the time progresses, their curves will eventually meet to a point where it will have an intersection, but not necessarily equilibrium. But at intersection, it means that the amount of these two will be the same, but they still continue with a certain trend. And after some time, you see that when they flatten, even with different amounts, still it's flat. The flat means the amount is constant. It doesn't anymore change. But it doesn't mean the equilibrium stops. The scooping still continues. There is still exchange of the products and the reactants, but the rate occurs at the same rate, at the same value. And so, in terms of amount, because the rate is the same, the amount should no longer change. So, as indicated with this. So, if the amount doesn't change, but you see that there is a difference between the product and the reactants, if the product is higher than the reactants, that means there are more products than reactants, you get a product favored chemical reaction in the equilibrium state. So you get more products than your reactants. If we think it the other way around, how will we now illustrate a reactant favored reaction? So let's now analyze that. If we have a reactant favored reaction, you will still have to start at zero for the products. Sorry, my pen is not functioning right now. And for the reactants, you'll always start at a certain value, then you go down. However, in the end, your reactant should still be of higher amount compared to your products. So when you trace this, when the two reaches equilibrium, the two must not be able to meet. So it's like at equilibrium, the two lines you see are two parallel lines, and the lines never meet. And the one on top will always be the reactant, and the one below will always be the product. And so, in summary for this video, remember that concentrations of reactants and products should no longer change with time, and for equilibrium to occur, no reactants and products should be able to escape from the system. And at equilibrium, a particular ratio of concentration terms equals a constant. So I hope that some concepts have been clarified in this video. So this has been Madam Narca saying don't stop learning, relearning and unlearning. If you've got some questions, please leave a comment. And if you like this video, please like, share, and subscribe to Narcademy. Bye!